All right, we are leveling up to the advanced level for Desmos, and on test number 17 has to do with family of curves. What a family of curves is, you've got a basic graph, which is usually the parent, and then you change some aspect of it. Maybe it's the slope if it's a line, maybe it's the y-intercept if it's a line, and you do a whole bunch of them all at the same time. That's the family. Like it has a whole litter of kids or something. And so it says plot a family of curves or lines using a list of numbers where a number would normally be. So a list looks like this. You want to, if you're just going to type in some numbers or whatever, if I type in, say, 1, comma 2, comma 3, it gives this little warning over here. And if you tap the little warning or hover your cursor over it, it'll tell you that lists are usually in square brackets here. So let me go to the beginning. My square brackets on my keyboard is hidden in the ABC menu. Yours, I believe, are to the left of P. All right, so you can see that it has a 3-element list. That just means there's 3 things in it. And if you wanted to, I can go dot, 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 and then comma, I think maybe a 10 or something. So now if you set up some sort of pattern that seems obvious, I should be able to just complete that pattern by putting some dot, 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 and then put the maximum number. I wonder if I can do the same thing for like 2s. Here, let me just go down here just to test this thing out. Not that this is necessary. Let's say I do 2, comma, 4, comma, 6, dot, 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 and then, I don't know, maybe 12. Yes, so it assumes the pattern and then continues the pattern there. Anyway, so basically what I want to do is I want to use these numbers, in my case 10 different numbers here, to plot 10 different lines or curves all at the same time. Now, in order to easily do this, I'm going to name this list something that I can call up inside of my equation. So I just put my cursor to the left of the first square bracket, and maybe I just want to call it A and then set it equal to, and it basically stores that as A. All right, and for some reason I lost all of my other boxes, so I'll just hit enter on this to get another one. And so for example, if I just hit A, you can see it just populates the box down, like the list of numbers down here. So here's what I'll do. I'll just play around with this for a second, and let's say that I do lines. So a line in slope-intercept form would be y is equal to our slope. So for example, if I just, no, equals, where's the equals? Yes, 3x plus 2, for example. I just have one line. But if I arrow over here to where this 3 is, and let me delete out the 3 and instead put my list A, you can see that what it did is it just graphed every single one of these 10 lines, each one of them with a slope of, well, first 1, and then 2, and then 3, and then 4, and so on. Well, and you might ask yourself, well, how can this be useful? One of the ways it could be useful is that maybe you're just investigating what happens when you change that little a value. That could be done with a slider too, to be honest with you. But something that might be more helpful is if you, for example, have a multiple choice test and you just put each of your answers in here. So maybe I have a 2, maybe I have a 5, maybe I have, maybe I have a 13, and maybe I have a 25. And these are answer choice A, B, C, or D, and you need to test those things out really quickly. Well, I could just make myself a list and put it where it's supposed to go in my equation and then test them all out at the same time. Okay, so here, let me get rid of this guy and let's go back up here. And just to play around with this a little more, maybe what I do instead is, so I just varied the slope, let's say. Maybe what I want to do this time is vary the y-intercept and see how that changes my lines for a given slope. So maybe this time I say my slope is like a half, and then x, and then plus my a. Now my a is going to be my y-intercept, and you can see that what this is going to do is make a whole bunch of parallel lines, and then I have a slope of y-intercept of 1, a y-intercept of 2, y-intercept of 3, and so on. Okay, so that's kind of neat. Here, let me turn this one off, and I think that at least one person, whoa, no, no, that's not what I want to do. I want to hit enter, did something with parabolas. So this is also pretty neat. So let's do something quadratic. So y is equal to, I'll use the a as my leading coefficient here, and then an x squared, x and then squared, and then you can see what happens whenever I graph all of these individual parabolas. Or if I wanted to, maybe I arrow over here and instead delete, put this as, let's say, a plus a, and then you can see that they are basically vertically stretching up, not stretching out, translating up there. Ooh, pretty cool pattern there. All right, so that should do it with a family of curves.